MSI Creator 15 OLED is straight overheating, throttling, dropping clocks and cranking up fans up to the maximum in a pathetic attempt to cool itself. In many other laptops, the same Intel Core i7-11800H scores in between 11 and 12,000 points in Cinebench R23. Here it is about 9,000, but the performance is not the main issue here. The laptop is just impossible to use comfortably as a laptop, putting the thing straight on the table and not to get crazy because of those stupid fans turning on and off randomly, thanks to those temperature spikes up to 95 degrees. Undervolting does help a little though. 400 or 500 points in Cinebench R23 compared to stock. And though this improvement is noticeable and welcome, it doesn't change the whole picture. The laptop is still underperforming and fans are still making me crazier than I already am. And if there are other safe and foolproof ways to fix video card VRAM overheating, here there's no other way. Repasting doesn't help, so liquid metal is a necessary risk I'm willing to take. Though I had some concerns at first, getting to know the subject made me confident enough to apply liquid metal and be sure that my laptop is going to be fine. I made a separate, very detailed video with a lot of theory on how to safely and properly apply the liquid metal, so definitely watch it carefully before messing with your computer. And this video is focused on specifics of MSI Creator 15 OLED and results we can get from replacing thermal paste with liquid metal. MSI Creator 15 OLED is hard to open, but it's getting easier every time you do it, which speaks a lot about build quality. Disconnect the battery. Carefully remove cooling system. If you are not willing to replace thermal putty, try your best to preserve it in the best condition possible. Don't try to scrape off everything with the purpose of reapplying it again. The stupidest idea ever. Scratch out some guidelines on the heatsink. Coat everything conductive around GPU and CPU. Practice assembling cooling system without missing anything. Make sure thermal putty is properly applied and there will be a good contact between VRMs and other components with heatsink. If there's nothing to leak, nothing will leak. If there's nothing to splash, nothing will splash. With that idea in mind, apply thinnest layer of liquid metal possible, put cooling system back, connect the battery, assemble the laptop and enjoy yourself. We know that with regular thermal paste, the laptop would hit 95 degrees and throttle, and with liquid metal, the laptop hits 95 degrees and throttles. Wait, what? It's true though, but only partially. And here is the truth. Cinebench R23, thermal paste in blue, liquid metal applied in gray. Though it still hits 95 degrees, still throttles, now it uses all that extra thermal room to perform 25% better. CPU package power. With thermal paste, the cooling system could handle only 40 watts of power. Now it's 10 watts more, which is the same 25% improvement. Clock speeds. 2.7 GHz sustained with thermal paste, 3.2 GHz with liquid metal. But there is something interesting on those graphs. In about 2 minutes, power drops from 55 watts to 50 watts. Clock speeds drop from 3.5 to 3.2 GHz. And temperatures drop from 95 to 90 degrees. It means that there's still some thermal room left. But now, with liquid metal, the laptop is not thermal throttled, but is power limited. The boost time is just over. I tried to change power limits in the BIOS, but those settings just don't do anything. Intel XTU doesn't work with Windows 11, and throttle stop is weird. Couldn't figure out how to make it work properly. If I'm able to disable power limits, there's still room for at least 5% improvements. So if you know how to disable those power limits, preferably in the BIOS, please let me know in the comments. It's not only CPU improvements. For Mark, for example, even though GPU was not undervolted or whatever, thermals are definitely better. With thermal paste, GPU throttles from 80 to 70 watts in 5 minutes. And with liquid metal, the graph is perfectly flat, 80 watts sustained. It's a fair 15% improvement, with no cheating here. Clock speeds showing this 15% improvement as well. Temperatures are 3 degrees lower, and they are more stable in general. Here comes my favorite part. Liquid metal allows me, finally, to take control of the fan curve. With thermal paste, fans were inconsistent, unpredictable, and very, very loud. I cannot emphasize how I hated the damn fan noise. Nothing but word. Nothing but damn word and chrome. Really, for real. But with liquid metal, it is completely different now. It allows me, for example, to make fans spinning at minimum all the time, and only when there's a big constant load, they start spinning faster. In everyday usage, temperatures are between 40 and 60 degrees, which is really hard to believe compared to stock. I can set the fan curve the way I want, and if I'm feeling like it, I can even turn the fans off completely. It is still fine for everyday usage. For example, YouTube is still playing 4K videos just fine, and temperatures rarely hit 70 or 80 degrees. But in this case, the laptop gets very hot and it's uncomfortable to use it on your laps. So the best scenario for it is, for example, you're exhausted today already, but still have some light work to do with documents, for example. So you can put your laptop on the table, turn off fans completely, and work in a complete silence. And sometimes it is exactly what you need. So I got 25% performance improvement on CPU, 15% performance improvement on GPU, and complete control over the fan curve. But on the other hand, I had to spend $20 and had to do some homework before the procedure. Apart from paying 20, it's a win-win. I had a very exciting experience and practically fixed the laptop overheating. For me, it's absolutely worth it, and I'm feeling like putting the damn liquid metal everywhere from now on. Liquid metal, all the things. Yeah, but we'll see that. Thank you for watching.